Hey, audience beings. So, I am going to now do a super quick summation of, or as quick as I can, summation of how I see particle construction and all of that sort of thing. So, have you seen before, if you watched my previous videos, the way I see it is that sort of the universe is, space is a fluid. It is a fluid of variable density. The density goes from almost nothing, which is in the deepest vacuum, to almost infinite, which is what matter is made out of, is very, very dense space. And inflows of space, or inflows, which are divergences where fluid is flowing into this universe, inflows create negative charge, outflows create positive charge. And yeah, so this is how I'm going to construct the universe as I see it. Okay, so first let's start with electron and positron. For this demonstration, we are going to use green is negative and red is positive. Black is just indicators. Fundamental thing about the universe, there are three dimensions. There are three dimensions. I don't know why exactly, but there seem to be three dimensions of space. Time is an infinitesimal. It's a single Planck moment, just enough so that there can be a tiny bit of inflow, an incremental inflow. If it keeps on going, then you've got a continuous inflow. Okay? And if you watch my previous video about manifold, you'll have kind of a handle on these concepts. So, now we're going to construct more complicated things. We are going to construct over here. Okay, let's do electron. And here it's going to be constructing an up, an anti-up, and a down, and an anti-down, and then we're going to construct a proton and a neutron. Just put all the pieces together. Okay, simple. Electron, very simple. Three axes. Three axes of negative charge. Positron, three axes of positive charge. Three axes of inflow, divergence. Three axes of outflow, convergence. Okay, so up is very simply almost an electron. Wait, no. Right, because you guys do these things so whack. Okay, so up is positive. Am I incorrect? Okay, this is embarrassing, isn't it? Yeah. I mean, really. This isn't important. See up. We'll do it this way, right there. Even though I think that makes this up and this is the anti-up, because your shit makes no sense. There we go. And then the down is only one axis. No charge. Okay, pretty simple. I know, you guys all know this. This is the way you guys make it. But I think we're just going to adjust some things. Part of this is this axes thing. Now, there we go. When you guys start putting together all those other strange constructions, what I'm going to ask you is very simple. Do they have three axes? Do they have three? This contributes to one axis. This contributes to one axis somehow, and it has two charges. One axis, I think it's because the charges are at the ends. This one's in the middle, but anyways. So when you put together a proton, you take two of these, up, right, anti up, that's down, that's the anti down, because you got it over. Okay, so we are going to take two ups. One up. Two, I don't know, let's just put it here. Ups. And then we're going to take it down. I'm going to put that down one. Let's use up this one because this is the one we didn't really want anyways, right? Okay. And now we have a proton. Now, what exactly happened here? We have a positron, but in the middle here, we have a positive charge and a negative charge. And a positive charge and a negative charge, a positron and electron, make a photon. And a photon, when you make it really, really, really tiny, and it's a very high energy photon because it was part of this kind of stuff, it can get trapped over its own Schwarzschild radius. And now suddenly you have a mass particle because you have a photon trapped over an orbit, its own orbit, the orbit of its own weight. And now what it gets is photon in orbit over a Planck. So this is 2 pi. There we go. In orbit over itself. This is how you get mass. And this is why NYC squared, because you get angular momentum, right? Exactly. Kinetic simple spinning disk, boop, here, going to there. You now have angular momentum squared, c squared. Mass is light trapped over its own gravity and acquiring angular momentum squared energy. Mass equals energy trapped over a Planck going at c squared. So where are we? Oh yeah, mass particle right there. So that's exactly what happened. We had a positive charge and a negative charge, and they started spinning over each other and created a little photon particle trapped over its own weight, and now we've got some mass there. And let's do the other one. Let's do the neutron. So we take a one. Shouldn't there be two ways of making it? One's called an anti-neutron, right? But they're exactly the same, aren't they? The only thing about neutron decay cosmology that might be appendix 2 if you watch my neutron decay cosmology, because my belief is that basically the universe works by taking neutrons decay into a proton and an electron, increasing volume 10 to the who knows what times, 10 to the 15th time if it happened here on Earth. But it's out in space, so it's going to be way bigger. Anyways, neutrons decay, become a proton and electron, huge, take up a lot of room, expansion. Over time, gravity, binding forces, etc., etc. Proton becomes neutron, and eventually it's a neutron star, which is only neutrons, and then it gets folded back into the vacuum energy and reappears in deepest deep space, pops open again, and now it's a proton electron again, and it's an endless flow. So let's make that anyways. What are we doing here? We can make a neutron or an anti-neutron at the same time. Let's take it this way. Boop. Boop. Two negative charges. Two negative axes. Oops. Two axes. Then we're going to take two of the reds. But they're going to cancel out. These are going to cancel out. There's the one. This is going to cancel out. There's the other. So this has two photons on orbit over the same space, and that may be where it gets its instability, because they'll set up perturbations within the orbit. whereas this is just like a perfect sort of like swirly egg thing. This is 2 photons, and the perturbation probably gives it the lifetime 14 seconds, which isn't bad considering none of those other things that you can construct that don't have 3 axes of charge or no axes of charge. 3 axes or singularity. 3 axes or singularity. Okay, this is the way it goes. Now, when you turn a proton into a neutron and you eject one of these positrons, you need this bonus particle. Neutrinos. And in my mind, neutrinos are like Aharonov boom particles, in that they are, one of them is an out swirl, that liquid drawn, out swirl, and the other is like an in swirl. One takes charge. See, this pulled the charge off and left only the mass. Why is there only 1 and 2 there? I think the mass just doesn't matter. Once you've got a 1 photon, it is what it is. It's like a mass particle, and a mass particle is a mass particle. So maybe every mass particle is unstable unless it has an attached inflow to drive sort of the mass particle, or to somehow keep the mass particle stable, the photon stable, so that it maybe the just a little bit of being different sizes, so you get precession, slow precession. I don't know. Anyways, one is an inflow, one is an outflow kind of spin. Aharonov bohm particles. This is why they don't have charge, so they don't really manifest that well. We detect charge. We detect things that have to do with charge. These are the different fields. Why does a neutrino have 3 different types of neutrino? 1 for each axis. Each of these axes could be attached to a charge, essentially, because if this was charge, then this would be electric, and this would be the magnetic fields. These are like the 3 generations of neutrino. It's the 3 facets of neutrino as it tumbles through space, because it's just spinniness, but it doesn't have an inflow or an outflow attached to it. When it connects to an inflow or outflow, then it can create a mass particle, because it will swirl it in or pull the charge off of it. Anyways, that helped anybody at all? I don't know. This is how I see particles.